Knowing that some of these questions in number 6 would have been a little tricky is inspiring me to choose a couple more examples that could theoretically pose a challenge, or examples that if you looked at the answer key might not have necessarily matched what you would have gotten unless you thought about the question a bit strategically. And it's not that any of these are really that much different than the others that we had talked about in the previous video or that you had done on your own. So you may find that if you got some of these questions correct, you can skip these videos. But this video specifically is going to walk you through question number 6, letter D, and question number 6, letter H. Because those are questions that I know historically students have asked about, because when they set it up or when they tried to clean it up, something just went a little sideways. If you have done questions D and H and you've checked your answers and you know you're okay on those, then skip this video because you obviously didn't fall into that trap. If I'm not going over a question that you personally do feel like you need me to go over, for example, if you need help on letter F and I'm not planning on doing a video for those, just pop into the next available office hours and I'll be glad to walk you through anything that I didn't anticipate needing to go over, because that'll help me make sure that I refocus and it'll help me better anticipate the needs of people so that next time I make a set of videos, I'll know which questions to target. In any case, I'm going to do in this video questions letter D and H so that you can see those two slightly more complex examples. In letter D, I'm going to do the same shortcut that I was using, the second fundamental theorem shortcut, that involves 3 steps. Canceling the derivative in the integral, rewriting the original function, just getting rid of the dummy variables, and then multiplying by the derivative of the upper limit. So, first step. I know that I'm going to have to take the derivative, so I'm just writing it, but again, this is just symbology. If you feel like you don't want to write it because you're just going to cancel it out anyway, that's fine. So step 1, cancel, cancel, and dt cancels as a formality. Step 2, recopy the original function, but replace all of my dummy variables. So my original function was something squared over something squared plus 1. And now I know that I am replacing those dummy variables, those t's, with the upper limit. So that upper limit essentially drops into place here and here. You don't have to do the arrows, but sometimes people find those arrows to be helpful, so you decide what works best for you. So the x squared drops into the top and the x squared drops into the bottom. So now I have that. Then the third step is to multiply by the derivative of what I just dropped in, the derivative of that new inner function. You can tell why I do parentheses when I write things out is because that tricks my brain into remembering the chain rule. The chain rule is always write out what you have, or the derivative of the outer function, times the derivative of the inner. And I always write the inner with parentheses to trigger that part of my brain to go, oh, right, times, right, don't forget, times. That chain rule can be easy to forget sometimes. So, having the parentheses is that trigger. The derivative of these inner parentheses is going to be 2x. Just because you plugged it in twice doesn't mean you need to multiply by 2 different 2x's. It's one motion, so it's one single multiplication. So just in case that confused you, you don't need to overcomplicate things. Now, of course, some cleanup. This is optional stuff. It would be fine if you left your answer like this. I'm sure even on the AP, if you had to do one of these, they would give you full credit for stopping right here. But if you wanted to clean it up, this is an optional step that you can follow. First, x squared squared would be x squared and another x squared, so that's x to the 4th. On the bottom, you have another x squared squared, so that's x to the 4th plus 1, times, still all multiplying by 2x. Technically, the 2x is over 1, so if you did want to clean it up as a fraction, the 2x is really only multiplying the top part. The bottom denominator is only multiplying by 1, so 2x times x to the 4th is 2x to the 5th, and on the bottom nothing's going to change, x to the 4th plus 1. Some people get a little carried away with the cleanup and they start to do crazy things like trying to split the fraction and do all sorts of reducing. I'll just remind you the rules of fractions are such that you can't split a denominator with a plus sign or any sort of additive property, so this is as far as it can go. It's not factorable, there's nothing else you can cancel or reduce. We can't cancel the x to the 5th and the x to the 4th because, again, it's additive on the bottom. Canceling only happens with things that are multiplicative, so you'd have to be stuck there. But again, remember, this is calculus class. We don't care about simplifying anyway, even on a good day. So don't get carried away with rules of fractions that you may or may not remember. The whole point is you did the freaking fundamental theorem of calculus. You should stop there. You have peaked as a human right there at this step. Don't go further. Don't go further than you need to. That's like climbing Everest and then going, I guess I'll run a marathon while I'm up here. Trust me, you don't need to. You've done a plenty difficult task. Leave it be. Question letter H, kind of the same thing, because I think the complication of looking at these answers is in the cleanup, and that's why I think students ask about question letter D and question letter H. They look at only the cleaned up version of the answer on the answer key and go, wait, 2x to the fifth, where did that come from? I didn't have that. And then they realize it was probably just the little bits of algebra. It probably wasn't the fundamental theorem, just the little bits of algebra. So in letter H, same idea. Let's go through the motions and just practice the steps. First thing I'll just do for formality's sake is remind myself that I'm taking a derivative, just so I can remind myself of why I'm doing this. So step 1, derivative, integral, cancel. Step 2, write out the original function, just leave a space and replace my dummy variable with the upper limit. So again, x squared is popping in where t used to be. So instead of t squared in my exponent, I'm plugging in my x squared. Then, third and final step, multiply by the derivative of that new inner function, the derivative of that upper limit. The derivative of x squared is 2x. Again, you've just climbed Everest. You've just done the freaking fundamental theorem of calculus. You've done something really important. You've peaked. You can stop right there. This is wonderful. This is perfect. This is a correct answer through and through. If you're still not satisfied because you still feel like there's more to be done, okay, you can clean it up. But you really don't have to. And I do want to implore you, you can stop right here. But if you want to clean it up because you just insist on cleanup and it's just going to make you more complete as a human being, then okay, don't let me change your style. If you wanted to clean this up though, just remember, 2x doesn't have any like terms. Everything else is in an exponent spot and they're not like terms at all. So 2x, if anything, could swing to the front. But e to the power of, I guess you could combine x squared squared as x to the fourth. That's as far as you can go. There's really nothing else you can do, because at this point you've kind of run out of rules that you can work with. We don't have any more exponents, we don't have any more terms outside, we don't have any constants other than the 2, so that's as far as we can go. Again, don't get too carried away with the cleanup steps here. So if you're looking at the key, where admittedly I personally cleaned it up, don't feel obligated to make your answers look like that. If you want to stop after the setup step and just leave your answers unsimplified, that is completely fine. If you haven't yet, make sure that you finish all of the examples in question number 6. If you have a question and the answer key itself, and these videos don't necessarily answer your question, pop into office hours and ask your question. In the last video, I'll go over a couple more examples just to make sure you're okay, but I do want to point out there are several more chain rule examples in question number 7, and I suggest you get a jump on them even before you watch the last video, because you may find that you don't need the last video at all if you feel this chain rule thing has already worked out well for you. In the last video, I'll definitely think about the fact, in the last section, not video, in the last section, question number 7, I'll definitely notice the fact that I have a couple of chain rule problems. Letter C is going to be a chain rule. I can tell because it's got an x squared as its upper limit. Letter E is going to be a chain rule. Again, it has x squared in its upper limit. Letter G is going to be a chain rule because it has x cubed in its upper limit. Letter A isn't going to be a chain rule because the upper limit is just x. I mean, you can treat every problem like a chain rule if you want to. You'll just multiply by 1. It ends up being kind of a trivial step. But if you want to think of everything as a chain rule so you don't have to remember those two different situations, when do you and when don't you, then just do everything like a chain rule and just multiply by 1. Who cares? It's your choice, though, and you can decide whether you're keeping this rule straight or not. In the last video, I'll go over a couple more examples, but specifically the kind that have the x in the bottom. So like letter F, to make sure that we understand what to do there, and some general tying it all together type comments. But if you feel like you've got the point, you don't have to watch that last video. Just practice, check the answer key, and pop in to office hours if you have a question.